things.
Yeah, I mean, that's half of the battle is just determining what's being said.
Outcome is whatever it's said on the top of that. Same thing as like that one.
Yeah, yeah, this is just 3 flips of a coin. So they're asking you questions on each one.
Okay.
Let's see, what about this one? All right. So again, there's 8. 1, 2, 3, 4, 5, 6, 7, and 8. It's just like the flip of a coin because it's even and odd. So that's why there's 8. It's going to either be odd or even, and there's exactly 3 of them.
Okay.
All right. So an even number on both the first and last roll. So we got to have E something E. This one won't fly because that's got an O on the first. But that one is correct. E, E, because that's the one at the beginning and one at the end. We don't care about the one in the middle. This one here, it's all O's, all odds, so not that one. This is E on the first, but not on the last. E on the first and second, but not on the last. No E's on the first or last. E on the last. And here's another one that's first and last. And again, that's going to be 2/8. Which is 1/4. Okay.
Okay.
An even number on the first roll. So if there's an E on the first, we're bringing it in. That's an O, but that's an E. This is another O, but that's an E. This one's got an E. That one's got an O. That one's got an O. So then there, and that one's E. So that's again, that's 4
Over 8.
over 8,
Gives you a half.
which is equal to 1/2. No even numbers on the first 2 rolls. No even numbers on the first 2 rolls. All right.
So then it would be that those
So no E. So we got to have. So this one has got an E on the second. This has got an E on the first and second. So not that one. But here it's got odd. So that one is no even.
Mhm.
This has got even on the first one, but not on the second one. What about this one?
No.
That's even. This is odd even. So not that one. But here's one that's got odd, because when we say no even, it means odd.
Mm-hmm.
And then the last one is even odd, so not that one. So
It leaves me with 2. 2 over 8.
and then that ends up being 1/4, 1/4.
Okay.
All right. So is anybody else working on anything that I could help with? Because I want to make sure that we do that this time, so I don't have to come up with something for you all to do. So anybody got any other ones? All right, let's see what I can find in the over in Alex. We can go to the book. So is there anything else, Amy, on that section that you're curious about? It looks like you got the right answers on all those.
Oh yeah, but I was just a little bit confused out of it. So because when I would put it in the system, it was marking it wrong, but
Mm-hmm.
I couldn't like finish it because it was like I don't know if I was like missing something when it was the check marks.
Hmm.
Yeah.
Well, you
No,
got those.
yeah, no, I got it. It's just it took me a while to figure it out. But I took
All
those
right.
pictures. It's just since you said if we had any questions.
Right.
Mhm.
What about these kind of problems? These are the ones with from 10.5 where you're just looking for the probability of a certain scenario, the denominators for each one of these problem sets, all of the A, B, C, D, and E ones, the denominator is going to be the same. So,
Let's do one of them.
all right, well, let's do this blue one then. All right. So what I want to do is we got 18 students. All right. 11 men and 7 women. So that's our 18 right there. 11 plus 7 is 18. And you'll notice that part of the challenge of working these kind of problems is some of the numbers they write out in words, some of them written out numerically. So we got to watch that. Now, here, right here, so that's 18 students. So that's going to be our N. So for the denominator, N is equal to 18 and R is equal to 4. Okay? So those are the things that we can glean from this right here. We're going to use these other things in a bit, depending on the particular problem. All right. Does that make sense? Has anybody got any questions about how I arrived at that N and the R?
What R stand for, Mr. Cruz?
That's your handful. That's the one that you're pulling out.
Okay.
The N is the total number in your bag, and you're reaching in blindly and pulling out a handful. I like to think of it as um, like pool balls. You know, they're all numbered and they got different stripes and solids, and that's a kind of a perfect example of what's going on here. So we're reaching in to that bag of 18 and blindly pulling out a handful, which in this case, the handful is 4. All right, so all men. Well, first of all, let's figure out what the denominator is going to be. And if I go over to the assignments and bring up that little calculator, that's the perfect thing to use at this point. You can do it by hand, but I'm going to try to save a little bit of time. All right. Now, where did it go? All right. So back over to that problem. All right. So my denominator is going to be, now just incidentally, are these permutations or combinations? I didn't really address that. So let's make sure we understand that. Permutations or combinations? Does it say anything about the students being picked? Is there anything there that gives a clue that we're ordering them?
No.
No, it's just 4 students being picked to make a committee, demonstration committee. So Okay. So now I'm going to draw this out. So this is our denominator. Okay. So I'm going to just figure that out using the calculator. So I'm going to put in the 18. Big number always goes first. We hit the C button because there's no order. And then we put in the 4. So 3060 is the number of ways that we can pick 4 from 18. So that's going to be our denominator in all these cases. All right, so all men. Okay, so what I'm going to do here is I'm going to put the just put the numerator here. So this is going to be C. And now, if I'm saying all men, how many men do I want to pick? How many do I want to grab out of that bag?
11?
How are we going to get 11 if we're only picking?
4.
Yeah.
Sorry.
Okay. But you're going to use that 11 over here because that's the ones you're picking from. In order for this to be successful, to have all men, the 4 we're picking has got to come from those 11. Can't have any of the other ones because those will spoil the men. So watch the calculator because I'm going to just have the calculator do the work for us. All right, so I'm going to put in the 11 C4 and I'm going to divide it by the 3060. Okay, so the 11 and the 4, the 11 C4, in other words, 4 coming out from the 11 men tells us how many different ways to do it. And we can look at that first. Whoops. We could just do this. And so there's 330 ways divided by the 3060. So let's round it off to tenths, hundredths. Let's run it off to thousands. So this one is going to be 0.108 because the 7 is what we want to round off to, the thousandths. So we go immediately to the right. It's an 8. So that tells us to bump up. 5 or above tells us to bump up. Less than 5 means just chop it off.
Will our test tell us what decimal to round to?
Yeah. There'll be one. Okay, this is the 2 possibilities. You, for chapter 10, you either going to have to round off to a particular decimal place because you can't just round off on your own. I'm doing it because they don't tell me on here, so I'm making the rules. You have to be told where to round off to. Now, if they say simplified fraction or simplified exact answer, that means fraction. Okay, and that means your fraction's got to be simplified. So, for example, on those ones that we were looking at, like we had 1/4, let's say. If we wanted to write this is a decimal, provided that it said we could put it in as a decimal. If it said simplified fraction, we would put 1/4. But in this case, when you round it off, something else happens, because this one will not have to be rounded because it's only got 2 decimal spots for it to have an exact answer. See, that's 25 over 100. Tenths, hundredths. The 2 is in the 10th spot, 5 is the hundredths. But yeah, they will tell you where to round it off. You cannot decide where to round it off on your own. And as a matter of fact, some of them will say simplified fraction or simplified exact answer, which that means fraction. Okay, so the numerator on this one, all women. All right. So here's our numerator. All right, we want all women, so we're only picking 4, so that means the 4 have to come from where?
Total number of people selected.
See the arrow? It's all women. All women. So how many women are there to pick from?
7.
Exactly. If we want all women, then those 4 have to come from those 7. All right. So again, we're going to round this one off to tenths, hundredths, thousandths. So what we're going to do is we're going to put this one in the numerator. I'm going to do the heavy lifting on the calculator. So now I've got 7 C4 divided by, now the same old thing, the one up here. Well, I'll tell you what, let's just do that first. So 35 is the numerator for all women divided by the 30/60. So then this one is 1, 2, 3. So we're going 0.011. All right. So we're going to that third decimal place. So over here 4, that means just chop everything off. If it was 5, we would bump the 1 up to a 2. All right, so 3 men and 1 woman. Now, when we have an and here, okay, and all 3 of these do, this simply means multiply, all right? So all of our numerators are going to have a multiplication in it because we're going to have 2 different things we got to pick, 2 different scenarios, 3 men and 1 woman. And so we're going to pick, just like we did for the top ones, out of the 11 for the men and the 7 for the women. So the numerators here are and so here's a multiplication symbol. All right. So this is the men side over here. It doesn't matter which one comes first, but I'm putting them in the same order. So how many men do we want?
3.
Right. And how many men are there in the group?
11.
1 woman. And there's 7 to pick from. So that's the numerator for this C. All right, let's go back over to the calculator and do it. All right, so 11 C3 times 7C1. All right, and just incidentally, let me just kind of point this out. But the two big numbers for the men and the women, the 11 and the 7, see, they got to add up to that 18. So that way we got them all. Okay, because you remember 11 men, 7 women add up to 18. And then the same thing with here. We're picking 4 right there, 4. So 3 plus 1 is 4. So that right there allows you to be able to check and make sure you got it set up correctly. Okay, so let's go over to the calculator and figure that out. All right, so that's going to be the numerator. So the good thing about the Alex calculator is it makes these easy to do. You can also do it with the TI. It's just a little bit more cumbersome because I could, in theory, put everything in here like this and get it in one. I'll come back and do that in a second. But
11
anyway, this is going to be our numerator divided by the same old denominator that we've been doing. And so that's going to give us, and I'm going to round it off to the third decimal place. And it's just going to go to 7 because we're going to that. The 4 is below 5, so we're just lopping everything off. All right, so let me just show you, in case you want to try this with the Alex calculator. This is really what it's good for, is doing these things. So what you can do is you can put it in your parentheses and then put it in the first one. You got to move, you got to hit the arrow key to move it because you don't want to multiply one that's down there. 7C1. Then we're going to close our parentheses, and then we're going to divide the whole thing by the 18C4.
I'll let you move it over.
Just use the arrow. Uh-oh, what happened? Oh, wait a minute. I got the wrong number right here. It's 3. There we go. Ah! Took it away. See, you gotta go down and make sure it's in the right spot, because that's considered a subscript.
Mm-hmm.
There we go. So now, see that 0.377. So you can get it to do the whole thing for you if you use parentheses. It's a little bit easier if you only have one of them, like for these, to get to do the whole thing. So again, just in case you're not following, this is the denominator for all of these. Because for these, we're picking from 18 our 4. And so there's 3,060 different ways to do it. So therefore, it ends up being the same denominator for all of these. All right, so 1 man and 3 women. So we're picking 1 man and 3 women, and we're going to use the same numbers because there's 11 men and 7 women. And again, the 7 and 11 give you the 18. And then the 1 and the 3 give you the 4. All right, so let's do it up here. 11C1. You hit the arrow key. Well, put in the 1 first for the 1 man. Hit the little arrow key over to the right arrow, because that brings you back up. So you're not in the subscript anymore. Then your times, and then you're doing 7C3. So that numerator is 385, and then we'll divide it by the 3060. And so we're rounding off to the third decimal place is 5. So on the right is an 8. So it's going to be 0.126. All right. So let's double check it by just having it do the whole thing. I want to key it in there, because I get a feeling that some of you might like to try this, because like I said, it's a lot quicker like that. Plus, like I said, if you find another way to do it, then you can double check, because you want to make sure, especially when you're dealing with testing stuff, that things are right before you submit them. And it's just human nature, even with me, to want to go quickly and think that I'm just right all the time. And I'm not right all the time. Most of the time, but not all the time. All right. And then the denominator is the 18C4, which is the 3060. And see, there we got it. Same one. The 5 gets bumped up to 6. All right. 2 men and 2 women.
So 2.
All right, so 2 on each one. 2 on each one. And see, just the same way the 3 and the 1 added up to 4, the 1 and the 3 added up to the 4 that we're picking, the 2 and the 2 add up to 4. And again, we're picking from the total number of men, which was 11, and the total number of women, which is 7. Okay, so let's get our calculator to do this.
Excuse me.
That's a 2. All right, so then that's 1155 in the denominator divided by
360.
3060. 0.377. The 4 means that we're just going to lop everything off over there. All right, so let's do it again and just see if it comes out the same. I'm going to put the whole thing in there. All right, so 11C2. And I should have my parentheses over here. So that way, if you don't do that, what will happen is, I'll tell you what, I'll show you what happens.
It moves. I just did that.
What?
It moves weird. It like it gives you another equation.
All right. So now, if I don't take it out of that subscript and you hit divide, see, it's only dividing the 3, and you don't want that to happen, because you don't want a fraction there. All right. So that's why we got to hit the arrow key to make sure it's over there. Now, let's say we try to divide now without putting those parentheses in. See, it's only dividing that one. That's not what we want to happen. We want to divide the whole thing. So that is why we need to have parentheses, because Order of operations. We want it to divide that whole term. So in the same way, when I calculated that first and then divided, I'm accomplishing the same thing by doing the parentheses. Oops, what happened? What in the world? I'm going to have to fix that because if I'm mistaking it for a 2, then probably other people are. But it's supposed to be a 3. I mean, it's supposed to be a 2. So again, let me just point out. All right, the 2 and the 2 need to add up to the 4. See, that's our R for the numerator. That was over here. And then the 11 and the 7 add up to the 18. So you can have it do the whole thing in your calculator, but as I said, it's very, very helpful to do twice to double check it because math is about accuracy. And the hardest thing to kind of for it to get through our heads is, okay, it's not so much that we're more or less setting it up correctly. We have to set it up correctly. And see, we got these like nice tools like the calculators to help us make sure that we're doing it exactly, because math is about accuracy. All right. Any questions about that one?
No, but this is like an example for like 10.5, correct?
This is 10.5, yes. All right. All right, here's something else we could do. And it's slightly different. Okay, all of those up there, all of the ones up here, up through 18, which is, the set we're working on, are combinations because there's no order when we're talking about pulling out a group of people if we don't give them any specific distinctions or order. But look at this one. All right. Number 22. A 5-digit identification card is made. Find the probability that the card will contain digits 0, 1, 2, 3, and 4. All right, so let's see if we can figure out before we start doing any calculations, what is this asking for? So let's just kind of look at an example of one identification card. It says 5 digits, so 3, 7, 9, 0, and 1 is an example of one of the identification cards. 5 digits. That's what a digit is. It's one of the single numbers, just like on the license plate kind of thing. So there's 10 possible choices for a digit. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. Each is chosen from 0, 1, 2, 3, 4, 5, 6. Let me save a little bit of room. All right, so for this, so here's another important piece of information. The 5, because there's 5 digits, So for this, and this is our denominator, what is n equal to? What are we choosing from?
10 digits.
The 10 digits. So that's 10. 0 counts as the 10th one. All right. So our denominator is going to be, I'll do it with this. P, and then we're picking our 5 from 10. All right, so this is our denominator right there. And we can use the calculator to figure it out. And then we'll come back and do the numerator. I always kind of have a penchant for doing the denominator first, since it's the big number. And you're going to have to, and in all the other cases, not for this one, there's only one time you're going to use it here. But for the other ones, there was multiple times we're going to use it. So anyway, it's 10. And so that's 30,240 different ways that we can pick the 5 digits from 10. In other words, there's 30,240 possible codes if we're selecting our 5 from the 10 numbers. Now, here's what they're asking us though. Find the probability that the card will contain the digits 0, 1, 2, 3, 4, 5 in any order.
That any order would have made me pick the combination instead of the pigmentation.
Well, okay, and I can see that, but this is still an identification card. No one can have the same code, okay?
Right.
So yeah, I can understand when it says in any order, but they're specifically just saying that you want them in all the possible ways they could be ordered.
I get it. Yeah, I'm with you. I'm following you.
All right. So this one is going to be P. So this is our numerator. P. And now we're picking 5. But we're limited on what we can pick from now. The favorable scenario for the numerator is we're not going to pick from all of them. We're going to pick from these. All right. How many are there? 1, 2, 3, 4, 5. So we're picking 5 from 5. Now, Felicia, you brought up a good question when you said it'd make you think combinations. But if we were picking combinations here, the 5 from 5, there'd only be one way to do it. But since these are codes or identification codes, there's going to be any number of ways to pick it. Let's see what that number is going to be.
120.
That sounds about right. Well, let's go ahead and just show it on the calculator. So 5 P5 is going to be 120. And so this is our numerator. This is our numerator. So then in the calculator, we put these two together. We're going to put the 120 and we're going to divide it by the 30 to 40. So that is going to be rounded off to the third decimal place. So the 3 means we look to the right and it's a 9. So we're going to put this as, oh, so let's go back and just double check it now by putting it in a different way. Let's put it in and just let the calculator do everything for us. All right, so at the top, we're going to have 5 C5, and then we're going to divide the whole thing by 10. Let's see that, same thing. Okay, so that's
You said rounded,
permutations.
right?
Just rounded the third decimal place.
Oh.
See, if we go to that one right there, it's 3, but we look to the one to the right, it's 9. So that means bump up the 3 to a 4. And that's what we had over here. So this one is good to go. I'm satisfied that that one's right. Really hard to get the same answer twice if you do it 2 different ways, believe me. And that's the way you're going to match up, is because you did them both the same way and they're both going to match. All right. Let's do one more of these. That's a permutation. And let's do the number 23. This one is kind of similar, but this one goes back to the example of a plain old a combination lock. And this is where you got to watch out. And let me write this here. So it's called a combination lock. Just you know, a lot of things in life that are misnamed, and you know, how it happens, we don't know. I mean, one of the things you think about is like with computers and such, they call the if you have like cable internet or any other type, actually, they have something that's often called by the cable company, they call it a modem. Well, it does the same job that a modem used to do, but a modem was specifically for taking analog and converting it to digital. But now they don't have to worry about it, but they still call it a modem. But like I said, it is. So we got to just realize that everything in life is named so properly. So a combination lock is actually permutations. Okay. So if you remember that, because the code for the lock has got to be in order.
Right.
So that's why it's a permutation lock. So let's try this one down here. So this is the one that has 40 numbers, 0 to 39. Remember that? You count in the 0, so that's why it ends up being 40. And it consists of 3 numbers. So this is the number we want for our N for our numerator. And then this is our R. So our denominator all right, let me write that in by hand. So we're picking 3 from 40. And if I remember this correctly, there's something like 59,000. But we want to be sure, so let's double check it. So 40 numbers, and we're picking 3 of them. So 59,280. That's how many codes are on the lock. In other words, quote unquote combinations. All right, so that's going to be our denominator. So our numerator, we'll start over here. Okay, so it's going to be slightly different. We're still picking 3 because that's what makes up the individual codes. Now, what is our n going to be here for this particular problem? Let me underline. And this is the key right here. We only want to use even numbers in our codes for the lock. How many even ones are there out of 40?
2.
How
Well,
many even
40?
numbers out of 40?
Oh, wow.
All right, I'll tell you what. Let's go up
19.
here. What?
19.
Well, I thought it would be half, but let's look. We can go ahead. So out of these right here, how many of these are even? That one, even.
Even. 5.
So it's half of them. Half of them are even.
Sorry,
So we're picking,
0 was even.
huh? Well, that's a good question. And there'll be some body that knows about math and say, well, 0 is not really odd or even. And you're probably right. So let's do it that way as well, because if it said odd, I would be confident saying half because I'm pretty sure 0 is considered neither odd or even. I think you're right about that. And then let's just go on and see what Google has to say. Is 0 odd or even? 0 is an even number, okay? And then I said is sometimes you will have somebody that will have a disagreement about it, but 0 is considered an even number.
Trust Google.
Yeah, well, I'm just saying that's what I've always thought it was considered an even. But I've heard people try to make a claim that says, well, 0 is neither odd nor even, but we're going to say it's even. So then this here is going to be 20
It-
P3. I'm sorry, no, it wasn't 3. What was it? I'm sorry. Yeah, that's right, 3.
You're right. It's
But
6,008.
it's half of the number. So now that's going to be 6840. So this is
Divided by.
all right. So let's go ahead and just put it into the whole, well, let's go ahead and take that and divide it by the 59,280. So 0.1115. No rounding off necessary because after the 5 is the 3. The 3 is below, so we're just lopping it off. So then this one is probability of even code is equal to, and then I'm going to double check it using the whole calculator to do everything for us. All right. Don't really need those anymore. All right. So up here, it's 20 P3 divided by 40 P3. And the same thing. So there, I'm pretty confident that that is the probability. 0.115, about 11.5%. All right. Anybody have any questions about this or anything else from 10.5? What I'm going to do is I'm going to go over and do something on 10.6 with the last 15 minutes, unless you got something else. Questions?
So that's how the homework's gonna be for 10.5?
Yeah, I mean, you're going to use combinations or permutations.
Okay.
And then also for some of them, as we saw, when you have an and, like for this one here, one of the last three, C, D, and E, see, for those, we had an and, because we're, in addition to using the combinations for the three men and the one women, we're using the counting principle, or often called the multiplication property, to, because that's two different experiments, picking three from the men and picking one of the women. So that's why we're multiplying.
Okay.
All right, so let's go over and look at 10.6, what they got, some stuff over there. All right, odds. All right. I might not be able to finish this, but we'll get as far as we can. It's really this one is a little bit different from the previous ones, where you have one kind of denominator and then you're only doing the numerator. Well, this isn't denominator numerator, but what it is the probabilities are going to change for each one. So we got to have probabilities for each one of these four, and then from the probabilities we create the odds. So just remember, odds for is A to B. Odds against is B to A. All right. When we calculate our probabilities, then we can find the A and the B that way, because the A is the numerator for the probability of getting, for example, the sum of 10. And then the numerator for not sum of 10 is going to be the B. All right. So the problem with this is you got to have that sample space. That's what I'm saying. We might just do one of each, for and against, like A and C. So I got to bring that up. Let's see if I can get that for us. All right, sample space. 2 dice. Find a good one that we can this one looks like a good one. All right. So the first one, it was asking for the odds in favor of getting a sum of 10. So what we got to do is we got to find the probability of sum of 10. All right. And this goes back to what we did in 10.1. So which of these sum up to 10? All right. So these sum up to 2. these sum up to 3, these sum up to 4, 5. Follow this line, 6,
Yeah,
7, 8, 9.
3.
In other words, it's this one,
Yeah.
this one, and that one, correct?
correct.
Yeah.
Okay, so those are the only ones that sum up to 10. They're all going that diagonal line. See, they're going along here would be 9. This is 8. Over here, it's 11, and that's 12. It's got a pattern to it. That's why that is one reason why this one. These are good to do because they're easy to find. All right. So the probability of a 10 is equal to, I think we said, what was it, 3? And there's 36 total. So that's 1/6, correct?
Correct.
See, 3 out of 6 times 6 is 36. 3 over 36. No, wait a second. That's not right. 3 goes into 36 12 times, right?
Yeah.
There we go. So this is 12. That. And let me just change one thing. So I'm going to try to write it in there. So this is 1 over 12. I like to see them like that. And that makes it easier to see. That's one reason why I don't like the TI calculator, because of the fact that you have to write in the fractions like you're writing it in, typing it in like that. So the probability of not 10, which is the complement, is equal to what?
112.
Now you can go through and use the complement rule and use how it shows you in Alex, where you got to subtract from 1 and then find the common denominator. But this is supposed to be the easy way. 1 from 12 gives us 11. So 11/12
Oh, no, Pete,
is
that's
the
right.
probability of not getting a 10.
Yeah, I'm tripping. Yeah.
1/12 is the probability of getting a 10. So 1 from 12 means that there's 11 that are not a 10. So A is equal to 1, B is equal to 11. So A to B is 1 to 11. Okay. So we're going to do this one. We did that one. Let's do this one. All right. And incidentally, I'll be covering 10.7 and the 120. So I can still have time to go over these if we need be. So if you got any other questions about them, we can do that. I don't even mind going over these. All right. So sum of 7. Let's go back over and look at our sample space. Sum of 7. All right. I was trying to see if I could move this.
6 over 36.
So sum of 7 is going to be
6.
there's sum of 7, 7, 7, 7, 7, and 7. All of those add up to be 7, correct? 6 and 1 is 7, 5 and 2 is 7, 4 and 3 is 7, 3 and 4 is 7, 2 and 5 is 7, 1 and 6. So as you said, Felicia, there are 6 of them. All right.
Mr. Crew, doing tests, will we be able to have the sample space chart? Would it be on it to you?
If it's, yeah, I mean, they should.
Okay.
Have you never had any of those? Because usually they got you. They'll give it to you.
Okay.
All right. So then the probability So it was 6, right?
Yes, over 36. 6.
Over 36. And this is the one that I'd mistaken up there because I had done these earlier. So this is 1/6. All right. So that means that the sum of not a 7 is going to be the complement. So 1 from 6 is 5,
5, 6. Okay.
5, 6. And so our A is the numerator here. See, there's our A. And this is our B. The A is over the probability of success, or in this case, the probability of a sum of 7. So A is 1, B is 5. Now we got to watch out because what they're asking us for is odds against. Odds against is B to A. So in this case, B to A is 5 to 1. Okay? So that's the two different types of odds. And then let's see.
Is it 1 to 5?
5 to 1.
1.
5 to 1. If it were odds in favor, it would be 1 to 5.
6 from 5 is 1. So
Mhm.
5. Where we get the 5 from, Mister?
You just said it, didn't you? 1 from 6 is 5.
Yeah.
I just heard you say it twice,
Okay.
right?
Right.
Am I
Okay.
missing something? 1 from 6 is 5.
Okay.
Because then the 1 6 and the 5 6 add up to 6 6, which is 1.
Okay. Not 7. Okay, got it. It's against it. Flip it and subtract. Okay.
And also too, and then when we come back, I'm gonna do another one of these, and then for the benefit of other people, but I'm gonna also do one where we go backwards from the odds to the probability. So anybody got any questions before we depart for a few minutes?
Mm-mm.
All right. Well, I'll see you in about 15.
We're going after,
Well-
we're going over this when we come back, right?
We'll continue with here, and then I can go over the whole of 10.7 in about 35 minutes. So
Okay.
I want to blow some time before I do that because I really can't just, unless we have something to do, I can't just let everybody go. All right.
No, I understand. So we're covering today's 10.7.
And then we'll go some more of 10.6 to
Yeah.
make sure you'll understand it. Because once you start working on it, I know how it gets a
Well,
little
the
bit
thing is
crazy.
that when it goes on that homework, it's just that sometimes it's just like it looks like word problems more. Like
Mm-hmm.
I don't know, it just gets confusing a little. Like
All
but
right.
with that, it looks different when you start explaining it.
Okay. Well, we'll come
Yeah.
back in a few. All right.
Okay, thank you.
Mm-hmm.